Hi students, welcome to this video where we'll be going through topic 14 from page 101 to 112. Now the video is pretty long because we spent a lot of time talking about the structured question, but I want to start first by getting you to make sure that you have your MCQ corrections done correctly first. You can pause the video over here. Now I won't be going through all the MCQ questions. I will only zoom into about 6 to 7 of them because these are the more challenging ones. And you also will notice that once you have figured out these 6 to 7, chances are the rest of the questions will be more straightforward to you already because they actually test on the same concept over the years, right? So I just want to highlight that for N level, the paper actually tests a lot on organic chemistry. And it's important for us to make sure that we can score every bit of the way as we go along. So let's get started. For this particular question on the first page of 101, I'm planning to go through question 2 and 3, right? So just a quick recap to make sure all of us are on the same page. Now, for question 2, alkenes, we know that alkenes has a general formula of CnH2n, right? Whereas CnH2n plus 1 is for the other homologous series known as your alkane, right? So just not to mix the two things up. And we know that alkene can actually react with bromine. Now, so what will it look like? This is actually what we call an addition reaction, right? In the addition of bromine with alkene, what will happen is that the red-brown color, so bromine is actually a reddish-brown color, will actually disappear, or what we call decolorize. So for this question here, we are looking at the formula of CnH2n. We are looking at decolorization of aqueous bromine, right? On the other hand, if you have alkane, alkane has a general formula of CnH2n plus 2, and if it's alkane, if you add it with just aqueous bromine alone, so you just put it with aqueous bromine, there will actually be no visible changes. Okay, so just to close the gap over here as we summarize for the chapter. Next, let's take a look at question 3. Question 3 shows this chemical with this very weird long formula, but don't rush and try to combine all the carbon together. And you know that there's 3 of the carbon, and in terms of H, there's actually 8 of them. Now this will be like our alkane general formula, CnH2n plus 2, right? Because C3, then the H is 2n, that means 2 times 3 plus 2. Total will be 8, right? This will be therefore an alkane. Yeah? So now if it's an alkane, we must remember that alkane, the reaction that they go through is what we call substitution, right? This is a difference. Alkene just now was addition, alkane now is substitution. Okay, so this is what the different types of reaction is about. Just take note of this key difference: alkene, addition; alkane, substitution. Let's move on to the second page now. On the page of 102, you realize that question 4 is actually the same logic of the previous question 2, right? But this time around they're asking about alkene. That's why you see there's no change when there's bromine water. But if it's an alkene, then there'll be a change, right? So for this question, what I want to talk about is actually question 6. As for question 5 and 6, sorry. So question 5, I just want to let y'all know that when you have something called unsaturated vegetable oil, what this means is that they have CC double bond. And CC double bond will mean that they are alkene. Okay? So when alkene is reacted with hydrogen, so hydrogen has a formula of H2, what will happen is that this reaction that happens inside is our addition, because we learned that alkene can go through addition. That means if you put this CC double bond with another chemical, addition can happen, and then you form a new product. For this question here, the product is actually a type of alkane. Now this is actually what we do when we want to convert from vegetable oil to, this is a fact that you need to know, margarine. Okay, this is one of the content that you must remember, that actually alkene reacts with hydrogen, and an example of this is the conversion from vegetable oil to margarine. This is an example that all students must know. This is a type of addition reaction, and the example is vegetable oil to margarine. Okay, so that's for question 5. Next question, which one shows a polyunsaturated molecule? Now students, you'll recall that unsaturated means that there must be CC double bond. Poly means that there must be many. So the question here will be many of the carbon to carbon double bond. That's for question 6. Alright, and then let's move on to the next page. For page 103, I would like us to go through question 9 as well as question 11. So zooming into question 9 and question 11. Which of the substance is formed when bromine reacts with ethene? Right, so just a quick recap. Ethene is a type of alkene. And once you see the word ETH, it means that there's 2 carbon. And alkene means that the formula is CnH2n. This will mean that ethene is actually C2H4. Right? So how will C2H4 look like? We're going to draw it out now. C2H4 will actually look like, draw the 2 carbon first. Because it's an alkene, it must have the CC double bond. Now, how do we put the H? Each carbon can have 4 bonds. So that's 1, 2, and I need 3, 4. So this carbon will now have these 2 H over here. Same for the other carbon over here. Okay, so take note of how to draw your structure, because you do need to draw it for the structure question. Later on we go to that. And when you react this with bromine, which is Br2, so Br bonded to Br, then let's take a look at what happens here. In a reaction like this, we know that alkene can go through what I call addition. I mentioned just now already. But the question is, do you still remember what is addition? You know, in class, we use some of the classmates as an example. We hold hand and we break apart the hand. So this will be, the carbon will stay here, but now it's just 1 bond here. The H should still remain. But this time around, because the bond is broken, the carbon must have 4 bonds, and they are now ready to make 1 new one with something else. And that's where your Br comes in here. And that's where your Br comes in here. Right? This is one way of looking at the whole drawing. Right? Another way to look at the whole drawing is also what you see in the answer key over here, which is that when they break it, they actually show that the H is on the side, over here, and then the bromine comes in from the top here. It's the same logic. Basically, the idea is that the carbon-carbon double bond must break first, then you welcome the new member to slot it in. Right? This is what addition is about. It's different from substitution. You might want to watch my previous video to recap about what is substitution. Okay, therefore the answer here over here is actually D. Then let's move on to 11. 11 shows you again, you see, margarine and vegetable oil. So if you remember what I mentioned just now, this is an example of alkene reacting with hydrogen. Right? So what happens in the reaction between alkene and hydrogen? To start off first, right, you must make sure that there is a double bond. Right? So the first one here, for A, there is a double bond here. For B, there's a double bond here. But then for C and D, you don't see a double bond at all. That's why C and D is totally out, because they are not even alkene. Right? To be an alkene, you must have double bond first. Then, what is the difference? It's reacting with hydrogen. So you must also check that there is a hydrogen here. It cannot be H2O. It shouldn't be water. And that's why B is also out. And they end up with just option A as answer. Right? So you realize that in MCQ, N-level like to ask about this reaction between vegetable oil and hydrogen. They like to ask about unsaturated, saturated. Right? So these are the similar stance of questions that they will ask about. Let's move on to page 104. For page 104, I'd like to zoom in your attention to question 13 and 14. So for question 13, you realize that there's this thing called cracking, right? So cracking is not new to all students. But I just want to remind you that cracking requires catalyst, requires high temperature. We all know that it goes from large to small. But we must remember that there is certain condition that's needed. Okay? And for question 14, once again, see? Margarine, vegetable oil, right? What is the reaction? It's about reacting alkene reacting with hydrogen. And we know that when alkene react, this kind of reaction is what we call an addition reaction. Okay, that means you put in the hydrogen inside and you break the double bond. Okay, so that's for question 14. Next, the last page on question, for this one, I will talk about question 15 and 16 to close off the MCQ portion before we move on to structured. Right. So for question 15, if you read the question, you know that there's a gas that enter into bromine, and then the bromine becomes colorless. If you recall this part, this will mean that there's a reaction, right? So what can cause bromine to react and become colorless? Is it because of alkane, or is it because of alkene? Because if you know whether it's alkene or alkene, then you can know whether what is the structure of the gas. So to just remind everyone here, the reaction happens not because of alkane, it's actually because of our favorite alkene. And alkene, we all know that it must have a CC double bond. That's why the question here, you need to be able to zoom in to know what is the structure. Alright, so what will happen, just to recap, the reaction, if it's this case, right, let's say you have CC double bond with the structure here, and let's say this chemical were to be added with bromine, the reaction, right? So what will form in this reaction is that the CC double bond will break, but then now the carbon is ready to take in one new friend, and that's why the Br will come in one side and Br will come in another side based on where the carbons are. Then you get this structure that you see over here. Okay, so this is just to additional information in case you want to know how the structure actually looks like. Okay, but of course you can draw it a bit neater, right? Using straight lines, up, down, left, right. Okay, question 16. A student makes 3 statements about molecules in food. Now, food will contain this thing called fats. Right? Most of the food will contain fats, right? So if food contains fats, right, and if you read this question, there's this thing called polyunsaturated. Now, polyunsaturated, what does it mean? It means that there must be many, and then unsaturated means there must be CC double bond. So to only answer this question about what does it mean by polyunsaturated, it will mean that there are carbon-to-carbon double bonds in the food. You wouldn't know whether the question is asking about hydrocarbon. You wouldn't know whether the question is asking about only carbon atoms because it doesn't say over here, right? It's only saying that I want to know what is polyunsaturated food, right? Anyway, hydrocarbon means that the compound contains only carbon and hydrogen, in case you're not too sure what this word means as well. Okay, and then for the last question, you realize that it's very similar to what we have seen in the previous few MCQs. Alright, now let's take a look at the structured questions. Now, for students who were around in class the other time when I went through the 10-year series, you can actually skip the video to page 109, and because we have went through most of the questions together already. Right, so let's get started. So this is for page 106, structured question 1. As we go through the questions, please take note of certain tips and tricks that will help you to answer the questions. Alright, so this question is about a hydrocarbon called C15H32, so quite a number of carbon, quite a number of hydrogen, treated strongly in the presence of a catalyst, and realize that the reaction is shown over here in this equation. Right, so what I see over here is that there's a C15H32 that actually became a C8H18, 2 of a C2H4, and 1 of a C3H6. Now students, whenever you read this question and you realize that you went from something that is large, one single structure, to many small ones, this is a hint that the process is cracking. Right? Cracking is about breaking up large hydrocarbons into smaller ones, and so this is one way to help yourself. Now the next question asks about the names of the products C2H4 and C3H6. Now just to clarify again, whenever the question is asking you for the name of the chemical, you need to start first by asking yourself whether it is an alkane or is it an alkene. Right? And how do we know that? There's a few ways to look at it. You can look at the formula, right? So for this question, we do look at the formula and realize that this formula C2H4 and this formula C3H6 actually follows the general formula of CnH2n, right? And then that will mean that it is actually a type of alkene. Alright, so if it's an alkene, the next question is that if it's 2 carbon, if it's 3 carbon, what will be the name of the chemical? So a bit of a recap now. We know that if a chemical has only 1 carbon, we start the name with meth. If it has 2 carbon, we start the name with FETH. If it's 3 carbon, we start with prop. And of course, if it's 4 carbon, we start with but. Right? This will affect how we actually name the chemical. So if it's 2 carbon here now, it will start with ETH. Now, what does it end with? Because it's an alkene, the name ends with a E and E. So that's why the first one is called ethene. The second one is 3 carbon. It starts with PROP, prop, because it's an alkene. It ends with E and E, and that's why we call it propene. Alright, I hope this is giving you some thoughts about how do you go about drawing the whole thing. Okay, now the next question, this is where we start to draw. Remember that in N level, they like to ask students to name, they like to ask students to draw the structures. And if you look at this chemical here, it's C3H6, which is our alkene. So just a quick recap, if it's an alkene, we know that they must have what we call CC double bond. This is what makes them very, very unique, right? So in terms of the structure of this chemical, just going to erase this and draw from scratch. I hope to remind you that alkene has CC double bond, right? So the carbon-carbon double bond. And in order to start drawing the whole thing, we always start first with our carbon. So this chemical has 3 carbon, so it's 1, 2, and 3. Because it's an alkene, we need to have a CC double bond. What about the other carbons? You can just leave a single bond, and that's good enough, right? Now, there's 3 carbon, and there's 6 H's. This 6H, you cannot just add it anyhow that you want it. You must remember that there is a rule. The rule is that each carbon can have or must have 4 bonds only. This is the point where we need to start counting, right? So we count to say that, let's say this is a carbon here, there is 1, 2, 3. So this carbon already has 3 bonds, but each carbon needs 4 bonds, right? That's why we add in 1 more bond, and this one will belong to the H. The carbon on the right side, this one, it has 1, 2 bond ready. That means it needs 2 more. That's why you add in the 2H. And the carbon on the left hand side here, it has 1 bond already. That's why you add in 3 more. Right? And with that, you actually get your structure of C3H6, which is propene, a type of alkene, by looking at the CC double bond and by making sure that each carbon must have 4 bonds. So you really must go and count and look at it carefully, one by one for carbon. So this carbon here now has 1, 2, 3, 4. This carbon here has 1, 2, 3, 4. And this carbon here has 1, 2, 3, 4. Right? So that is how you actually use to count and double check your answers. Alright, so let's move on to the second question. Now, the second question gets a bit harder now, so there's a few notes that I need to take note of. The second question looks at P, Q, R, and S, and you're asked a bunch of questions. What is saturated, what will decolorize aqueous bromine, and what will take part in addition reaction. If you have watched my summary video, you'll know that for saturated, what it means is that the chemical only has CC single bond. This will mean that things like this, that means it doesn't have double bond. Things like this, that means it doesn't have double bond, would constitute what we call saturated chemical. So it should be P and S. Now, what about reaction with aqueous bromine? If you recall, aqueous bromine is a chemical that is reddish brown in color. Right, you can take this down as we go along. And when there's a reaction with a chemical, the reddish brown actually disappears, becomes colorless. That's what I call a decolorize. Right? And this happens for alkene. So what is special about alkene? We mentioned just now earlier, they must have C double bond. So this will be my alkene, and therefore the next answer is for Q and R. Last, taking part in addition reactions. Now, addition reactions are only for alkene, right? So I think we learned this in our notes before, and therefore the answer again is Q and R. So this is for the kind of things that you see over here, but the question can ask a lot of other things. For example, what if the question asks about unsaturated? Now, unsaturated would mean that there's CC double bond. Now, what if the question asks about substitution reaction? So there's 2 types that you learn, addition and a substitution. The substitution will be for alkenes only. Right? So you can see that actually as you learn about the chapter, you need to be prepared to understand the meaning of saturated, unsaturated, the meaning of addition, substitution, and know what kind of chemicals you're looking at. Alright, and then we'll move on to the next page. Next page is asking about the process by which liquids such as petrol and diesel are obtained from crude oil. This is about separating, right? This is not the same as cracking. It's from crude oil. I want to separate to get petrol and diesel. Now, how do we separate such chemicals? Right? How do we separate this mixture into different things? And that's where we have our fractional distillation. Just a quick recap, fractional distillation is based on different boiling points, right? So chemicals with the lower boiling point will actually be separated first at the top. Chemical with the higher boiling point will be separated last at the bottom, right? So this is what you can revise from topic 13. Next question. This is a chemical called pentane, C5H12, and then the equation shows one possible reaction that can occur. If you look at it again, you realize that there's one big one, C5H12, becoming many smaller things. And if you count the carbon and hydrogen, you will realize that Y is actually C2H4, right? So you can count how many carbon, how many hydrogen, and it must add up to the left-hand side, right? So this process is once again cracking, right? Because it's about going from big to small, like what I mentioned earlier, right? And how do you name compound X? Compound X, if you take a look at it, the formula is C3H6. That means it follows the general formula of CnH2n. That means it must be an alkene. Okay, it has 3 carbon, so it starts with PROP. Because it's an alkene, the name will be propene. Yeah. Next, we have drawing of compound Y. So if you have done the comparison properly, you know that compound Y is C2H4. So once again, C2H4 follows the general formula of CnH2n, and that is once again for alkene. So we're going to start drawing now that we draw the carbon first. So there is 2 carbon. Because it's an alkene, and we know that alkene must have CC double bond, right? So if you have a CC double bond, then we need to draw it in here and end up with this. Formula says C2H4. That means we need to start counting. We know that this carbon here has 1, 2 bond. It should have 1 more and 1 more, total 4. So this carbon will be like this. The other carbon, similarly, 1, 2 bond, and therefore it should also have 2 more. And then double check, and you realize that yes, this is indeed C2H4. So this is what you need to do over time to get used to the drawing. Draw it step by step. Draw out the carbon first. Moving on. The next question is about mole. Right? When it comes to mole, I know a lot of students will start to be very, very stressed. But I want to remind you that we start with the formula of the chemical. If it's C3H6 in this case, let us first break down the chemical and understand what's going on. This will mean that there is actually 3 of the carbon. So what it means is that there is carbon, carbon, carbon. This will mean that there is 6 of the hydrogen, which will mean that there's hydrogen, 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 and hydrogen. Before you can do any mole calculation, questions about mole, you need to know what's the MR, right? So MR of this chemical must be to count the mass of each of these atoms and add them up all together. If you look at the question was very kind. It mentioned relative atomic mass. So it told you that, okay, carbon is 12, hydrogen is 1. Or you can use a periodic table to help you, right? So over here, the MR will be, I have 3 of the carbon here. So you can do multiplication if you want, 3 times 12, or you can just 12 plus 12 plus 12. Okay, but there's 3 of the carbon, because each of the carbon is a 12. Then there's 6 of the hydrogen, whereby each of the hydrogen is a 1. So you add it up with 6 of the hydrogen. Now do it slowly, because this is 1 whole mark. Don't waste the mark away, right? Then this will give you 36 plus 6, and then there will be 42. So do show your working so that people know what's going on. Then the question is about finding mole, right? So remember mole, there's a formula. It's called mass in terms of gram divided by the MR of the chemical. So this question actually gives you the mass already. It's 21 gram. So this will be equals to 21 divided by the MR. And the MR is based on what you calculated just now here. And you bring this up over here. Divide by 42. Use a calculator, don't need to rush. And this will get 0.5 mole. Okay, and that is for this page of the 10 series. Moving on to the next page on 108. Once again, you can see that if you read the question carefully, there's something called decane, and they mention about crack. Right? So this must be a form of cracking. And cracking means that if you have to know what's the molecular formula, you must add back the carbon and the hydrogen. So go and count how many carbon and how many hydrogen. You should end up with C7H16. Right? So you count one by one. So the carbon here there's 10, here there's 3. So it's 10 minus 3. This will be the number of carbon. H will be 22 and 6, which is 22 minus 6, for example. Something like that to use to help yourself. Okay. Next, you're asked to draw propene again. Propene. Propene, the formula is given here C3H8. Okay, propene, the formula here is C3H6, which means that it is once again a type of alkene. So alkene means must have CC double bond. Right? So we start by drawing carbon first. So there's 3 carbon here. 1, 2, 3. Then let's put in the double bond. Then the other side is just a normal single bond. Then now we count. Each carbon must have 4 bonds. So this carbon here has 1, 2, 3. So it needs 1 more. This carbon here has 1, 2. So it needs 2 more. This carbon here has 1. So it needs 3 more. And there you have it. This is your C3H6. Alright, so that is how the drawing works. Right, always go step by step. But you must first know whether it's an alkene or an alkane, because the drawing is very different. Yep, let's go on to the next page, 109. Now 109 is about cracking again 1A. You guys said the question a lot always starts about cracking. So over here there is a reaction of C10H22 plus C2H4 plus C3H6 plus something. So same thing we are going to count, right? So if there's 10 here, and there's 2 here, and there's 3 here, we know that we're ending up with 5 more of the carbon, right? Then in terms of hydrogen, there's 22 here. Sorry, there's 22 here, there's 4 here, and there's 6 here. If you count the H, you know you end up with 12 over here. So this is C5H12, right? Name an unsaturated compound produced in the reaction shown above. Name, that means the proper name. Unsaturated means CC double bond, remember? So this must be a type of alkene. Okay, alkene would mean that the formula must be CnH2n. So if you go and look at each of the thing on top, you realize that the one that is CnH2n is this one or this one. So you have 2 carbon or you have 3 carbon. So you can choose either one to name it, and it could either be ethene or propene. Next question asks students to draw the structure of C2H4. Now this is a bit more challenging because C2H4, if you follow what I'm talking about just now, you know that it has a structure like this with a double bond. Now drawing a line across is going to be difficult, right? Let's take a look at how the drawing looks like. So this is a drawing of C2H4. It will involve the 2 carbon in the middle, and we know that every double line is actually a pair. Each line is actually a pair of electrons. So double line will be that there's actually 4 electrons here. Then the single line will represent a pair, a pair, a pair, and a pair, right? And then we have our legend on the side, right? We'll go through this more when we're in class, but this is how the dot and cross structure of the molecule looks like. So take note of your corrections first. Next question, they're asking that, okay, there's 2 samples of the compound C6H14 that are burned separately under different conditions. The first one produces water and a gas, which gives a white precipitate with lime water. The second one produces water and a poisonous gas, which does not give a white precipitate. So you're supposed to find the gas which gives a white precipitate with lime water, and in our syllabus that will be carbon dioxide. Next question, what will happen if the gas is bubbled through a neutral solution of universal indicator? We know that carbon dioxide is acidic, and we know that neutral universal indicator will be green. Okay, and we know that if it's acidic, the color could be red, orange, or yellow. Right, so over here, if you bubble the carbon dioxide in, the color will change from green to either red, orange, or yellow. But it's most likely going to be yellow because carbon dioxide is a weak acid, right? So this is how the color will look like. In terms of the poisonous gas produced by the second sample, chances are it's because this poisonous gas is a case whereby at the start you have carbon dioxide, but if you have not enough oxygen, you actually end up with carbon monoxide. And why is that the case? It's because depending on how much oxygen there is, there can be either this thing called complete combustion, or there can be this thing called incomplete combustion. Incomplete combustion will give you carbon monoxide. Complete combustion will give you carbon dioxide, right? So take note of these differences. Complete combustion is when there is excess oxygen. Incomplete combustion is when there's limited oxygen. It's something that you have learned before in this chapter. Alright, then let's move on to the second page. For the second page of question 2a, the question is asking for the relative molecular mass of the compound X. Similarly now, because the question is asking about mass only, not mole, so let's go and work out how many carbon, how many hydrogen first. C2H4 would mean that there's 2 of the carbon, so carbon and carbon. H4 would mean that there's 4 of the hydrogen, which means H, 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 and H. This will in turn give me a mass of 12, 12, 1, 1, 1, 1. So in this question here, the MR will be equivalent to 2 times the 12 plus 4 times the 1, and you'll end up with 28. Right? And we're supposed to draw compound X. Compound X is C2H4. The rest of the formula follows CnH2n, which means that it's a type of alkene, which means that it must have a CC double bond. So same thing, draw out 2 carbon first. Since there's a double bond, we put in a double bond and we start to count. This carbon here has 2 bonds already, it needs 2 more. So then you have a H here and a H here. This carbon here has 2 bonds already, so it needs 2 more. So you need a H here and a H here. Okay? So the process by which compound X is manufactured on a large scale from hydrocarbons, and give one reason why the industrial process is important. So compound X is a small chemical, C2H4. How do we make it from other chemicals? That is once again our cracking process. Right, so cracking is the one that allow you to obtain all the small compounds. Why is this important? It's because cracking allows us to break down large molecules into smaller ones, which can then be used as fuels, so to give us energy, or to form other chemicals. So this is always the important part about why cracking is important. Okay, moving on for propane. Propane is C3H8, it's another hydrocarbon. You're supposed to write a reaction to show the complete combustion of propane. So just a quick recap. Combustion means that you react with oxygen, and because it's complete combustion, you will form CO2 and H2O always. So you must learn how to write this equation. So for this question here, C3H8 will plus O2 to form CO2 plus H2O. Okay, but there's a need to balance the equation. So you take a look at how many carbon are there on the left hand side and right hand side. So on the left hand side, if there's 3 carbon here, on the right hand side we'll put a balancing of 3. On the left hand side, if there's 8 hydrogen here, over here is a H2 already. So you must take note that whatever number you put over here is actually a multiplication. So this will now be 4. So this is 4H2O because there will be 8 hydrogen in total. Then let's count the oxygen. So oxygen here there's 3 of the O2, and here there's 4 of the O. This will mean that in total there is 6 sets of oxygen here, because 3 times O2, right? So each of the O2 is 2 oxygen, so 6 of the oxygen. On the right hand side here is 4 sets of the oxygen. So total on the entire right hand side there's 10 of them. On the right hand side there's only 2 here. So you need to put in a number here to make sure that the number is also equals to 10. Right, so I repeat, over here on the right hand side there is 6 of the oxygen, then there's 4 of the oxygen, so total there's 10, and then on the left hand side you also need to have 10 of the oxygen, and that's where you put in a number 5 over here. Okay, so that is how the equation goes about. Last, the question asking about the burning of propane in limited supply of oxygen. Now, limited supply of air would refer to this concept of incomplete combustion. Right, so if it's an incomplete combustion, like I mentioned earlier, the product will be carbon monoxide as well as soot for the chemicals. Okay, if you are done, we will get ready to move on to the next page. So, on the next page of 111, right? On the next page of 111, we know that this question is now asking us about the chemicals called ethene as well as propene, which are our unsaturated hydrocarbon. So, students, a quick recap. Unsaturated will mean that there are CC double bond inside, right? And this is therefore our alkenes. And the question starts off by asking a student about what is the general formula of the alkene homologous series. Now, alkene will be our CnH2n, right? The next question then goes on to ask about this thing called homologous series. What is the properties of it? Just want to recap that homologous series refers to a family of organic compounds, right? So, for example, so far in our notes, we have learned about 2 types. One is what we call the alkane family. One is what we call the alkene family, right? For those students who take O-level, they will learn about other types of homologous series, but for us, we are focusing on alkane and alkene. When it comes to alkane and alkene, right, as a whole, when we talk about this thing called homologous series, when you are asked about properties of homologous series, we need to remember a few important ones. Number 1, we need to know that all the chemicals in the homologous series should have similar chemical properties. So, for example, all types of alkenes will go through addition, because this is the chemical property of the homologous series. So any alkene, be it ethene, be it propene, be it butene, so on and so forth, they will all go through addition. That's similar about them. Second one, important property is that they all show a gradual change in physical properties as their molecular sizes increases. So what do I mean by that? So let's see a few examples. We know that in a homologous series, there's many different alkane and alkene based on how many carbons there are, right? But as we go down the homologous series, we know a few things will actually change. Number one, we know that melting point and boiling point will actually increase. So this is what I call a gradual change in physical property. We know that things like viscosity will increase, so on and so forth. We know that things like the MR will increase because there's now more carbon, more hydrogen, so on and so forth. So these are all what we call gradual change in physical properties as we go down the homologous series. Okay, so take note of this whole part in terms of the notes itself. Next, the question is asking, oh, what will happen if we react the bromine water with the unsaturated hydrocarbons? Now, unsaturated hydrocarbons means alkenes, right? And we went through this just now. Now we know that bromine is actually reddish brown. So if there was a chance for the reaction between alkene and bromine water to happen, the reddish brown bromine color water will actually become colorless. This is what we call a decolorization. So we say that bromine turned from reddish brown to colorless. So we must take note that in our notes, right, or in the way that we answer question, it must always go from what to what. Don't just say that it decolorized. That's not good enough. It must be turned from reddish brown to colorless. You must say that before and after, right? And how do we show this in the equation? We know that ethene is C2H4. We know that bromine is a group 17 element, so it's Br2 diatomic. Now the addition reaction, the good news is that the reaction is just to form a product whereby the two formula comes together. So it's literally taking the Br2 and adding it back to the original formula, and you end up with C2H4Br2. Now this is called addition, right? In case you are not too sure about what exactly is happening over here, let me show you a drawing. So for this reaction here, what actually happened is the alkene ethene actually looks like this. It was reacted with bromine, Br2. So if you still remember what we discussed in class, when this reaction happens, the alkene will actually break one of the double bond, and then it will welcome the new Br to itself, and then you end up with this structure that you see over here. So this is what the addition reaction is about. Basically, the alkene and a bromine molecule is just an adding on of the structure. It is very different from substitution, as what we went through just now in the MCQ. So it's important for you to take note of the difference between substitution as well as addition in terms of their products. Then now let's go to the last question of this video. This last question is a challenging one. It's about graph, right? So in this question here, you're shown about different kinds of the alkene. You're shown the different types of number of carbon atoms that they have, and you're shown the different boiling point that they have. On the next page, you are asked to plot the graph. Now, plotting a graph is like what you learn in math. You need to count and see the number of boxes and what they represent. So let's take this first one as an example. 2 carbon for negative 104 degrees Celsius. 2 carbon will trace to find out if it's negative 100, this will be negative 112, this will be negative 114. And then we just put a big cross over here at this point as neat as we can using pencil, and that will be our first point. If you repeat the same thing for the second one, which has 3 carbon for negative 48, so similarly if you go back to the graph, we'll follow the x-axis, find the 3 carbon, we'll trace back up to find where is negative 48. So this is negative 40, this will be negative 42, negative 44, negative 46, and negative 48, and this for 3 carbon. So then we put a cross over here. If you repeat the same step over and over again, you will end up with these 5 crosses that you see over here, and that's what already give you one nice mark. So I'll remind all students that it's not that difficult to draw out the plots of the points of the data. Right, so you should try to make your best effort to aim for this whole thing. Now the second question will be a bit trickier. What is a curved line of best fit? Now a curved line of best fit is a line, a curve, that actually passes through most of the points, right? And it allows us to see the pattern in the data. So it could look like this. If you follow my red highlighter, a curve that looks like this, whereby it passes through all the points that you see over here. So students, you need your curve ruler, right? You cannot just draw a curve using freehand, then you end up drawing this, and this. This will be a very bad graph. Neither should you take a line, a ruler, just join all the dots and combine them like that. This is also a very bad graph. A curve of best fit requires you to draw a smooth, neat, one-stroke curve across all the points, right? So it might look something like this, right? Whereby it passes through most of the points that you see over here, and that will be what we want to see in your work, and this will be your 1 mark. So bring your curve ruler along for all chemistry papers from now onwards, including your calculator. The next question actually asks us to determine what is the boiling point of pentene, right? Pentene, we know that based on the question here, is actually having a missing data, but we know that there's 5 carbon. So what this will mean is that we can actually trace by the 5 carbon. Now we have a graph, right? Go up and see where it hits the curve, and then we trace to the right hand side. This will be our working. Then we will be able to find out what's the temperature. Then that will be 1 mark of the answer. So as a student, you do need to show your working by indicating where you're starting the counting from, and then showing people that you know where the data point will be at. So based on my graph over here, different students will have different graphs. You need to work out your working line upwards, and then making sure that it touches the new line that you draw, and then trace out what will be the corresponding temperature. So in this case, if I follow my data here, from 5 carbon, if I trace up a vertical line, I'll hit the graph somewhere here. And then if I cut across the left hand side, I'll see that the graph is somewhere here. And this will be equivalent to 32 degrees Celsius. So therefore my answer here should be 32. But your graph might be different. You need to look at your own graph, and you need to see what's the data over there. Alright, and with that, we have come to the end of this video. This is not the entire TYS series. The rest of the questions we'll do it as we come along. Then that will be part of our revision as well. That's all. Bye bye.